Good evening, everyone. This is a review of the classwork assigned for 318 1.3.3. And what we're doing is we're investigating reflections. So let's take a look at letter B. So if g of x equals f of 1 over b times x, where b is minus 1, complete the input-output table, and we're going to graph g of x as f of negative x. So in general, if g of x equals f of negative x, how is that related to the original f of x? So let's just take a minute and let's recall. Whenever there was a negative out front, it didn't matter if it was a parabola, exponential, what did that do? That a out front that was negative, if you recall, caused a reflection over the x-axis. So if a negative outside causes a reflection over the x-axis, what do we think a negative on the inside will do? Well, f of negative x will cause each of the x's to change signs. So if x was 5, f of negative x will become negative 5. So it's not going to change our y values. This is going to change our x values, which is going to cause that reflection over the y-axis. Please note the y's do not change. Only the x values are going to change. So let's take a quick look at the input-output. Again, this is in your assigned workbook pages. And so I've made the input and output for G a different color than the F's input and output, just so that it's easier to actually see. So the F's input and output is given. -1 maps to -2, 1 maps to 2, look at the red, 3 goes to 2, and 5 goes to 2. Well, what's the relationship between the G's input and the F's input? Well, they are inverses of each other. So if F is -1, well, the inverse of that, or multiplying by -1, would give me 1. And so each of those are going to be the inverse of one another. So 1 is -1, and 3 becomes -3, and 5 becomes -5. And again, this is going to cause us a reflection over the y-axis. So let's take a look at a graph, and let's take a look at what happens here. So if you look at the given graph, f of x is in black with the dots in red, and that's what you'll see in your workbook. So I went ahead and I labeled those for you. So the first red dot is the name of those coordinates is -1, -2, +1, 2, 3, -2, and 5, 2. Now remember what I said, your y values are going to stay the same. So the range is going to stay the same as the domain that's going to change. So each value of x, you are going to basically be flipping it over the y-axis. So -1 becomes +1, +1 becomes -1. Note they keep the same y values. This 3, -2 is going to jump over this way and become -3 over 2. And this 5, 2 is going to become -5, 2. So again, if you look, if you could imagine a spatula and you're making pancakes, you'd slip the spatula under, you'd flip it over, and so if you see, that is actually the reflection over the y-axis. Okay, so let's go down and we need to do the reflection questions that are underneath. So we'll do these one at a time. The first reflection question says, if f of x reflects, in the domain from x1 to x2, means from x1 to x2, and given the range of y1 to y2, and again, please note that that is interval notation. Those brackets indicate that the endpoints are in fact included, and I wrote that right here. So what's going to happen? If f of x reflects over x-axis, what's going to happen to our domain and range? Well, in fact, our domain is going to remain the same, but it's going to reflect and it's going to flip. And so my y values become -y and negative y2. Again, this is a reflection over the x-axis, which is the opposite of this one. This is a reflection over the y. We're doing a totally different thing. This is like when we had the parabola and we flipped it over the x-axis. So if you flip it, you'll notice that the x's don't change, but the y's are going from above the x-axis to below, or if they started below, they're going to go above. And so that's why we would multiply each of those by a -1. Now let's continue on. Reflect question number 8 says, f of negative x reflects f of x across the y-axis. So what happens with our domain and range? Well, the range y1 to y2 will stay exactly the same. What's going to happen to the domain is the domain is going to change. Now, this is a normal regular old graph. This is what would happen. This is what happened in our scenario that we were given. But that's not what question number 8 says. Number 8 says, what would we know about the graph if we do a reflection over the y-axis and it still looks exactly the same? So what I did was I drew you 2 examples of how that could happen. If I were given a parabola, and I said, okay, flip this over the y-axis. Well, if I flip it, the parabola, since it's symmetric about the y-axis, is still going to look exactly the same as the parent function. That transformation makes no change. If I have this graph, which is a degree 4 graph, if I flip him, well, he's also an even function and is symmetric about the y-axis. So when I flip it, I would not know the difference. Even if I now painted it blue instead of red, it would look exactly the same as a parent function. So that is the answer to number 8, is it would look exactly the same in the event that we had an even function. So I wrote the answer is an even function. And if you want to, you can draw either the parabola or this lovely function down here. Both of those are even functions.